Hello, my name is still and yet already Andrei Kulikov, and in this video I'd like to talk about another contest in Kaggle that is now active and where I can experiment and use my few knowledge about machine learning. So this is a contest. My place now is 201, and you see the difference between the result, the score. Uh, there are 10,000 okay. You see the difference, yes? The amount of people is the following, so I'm in the third part of of the results. So what is the idea of this contest? It is very simple. You have train data and test data, and you using this test, you have to predict some values that uh, on which this system will count your score. So data overview, and the results must be the following: ID and the cost. Very simple task, but not simple. So here is the code. I used many things. Some of them were successful, some not, but it is very important in development of my knowledges. So here is I load the data sets. Um, what I see here? I see here that it must be scaled. So here is they differ great at the first sight, and it is evident. So next I look for missing values. I drop the ID and the target value and get the X, and get the target value. Then I do scaling and I get the scaled data. It is very beautiful. Okay. Then I have to find the correlated data that are similar or near similar, and I see that salad bar is similar as prepared food, and I have to delete one of them because it is unuseful and can influence on the results in a bad way. So I'll do it, but later. Then I made an experiment with normalization of data. It's the first experience in real work. So here is my the distribution of my data in original, and after using box Cox normalization. Where is it? Box Cox. It was in Kaggle courses. I use the distributed data, no normal distributed, yes, but it did not affect on the score on the uh, results of the contest at all. And appeared some strange data here. It became negative, and appeared some nuns. So maybe I'm doing something wrong, or maybe it is not need to do something with normalization. Okay, so here is another plot on correlation with meanings, not only colors. See one again, and other data is not correlated and no need to delete it. Okay, so then there is a thing that is called mutual information. Here is the code for this, and I see. So this information tells us how many information of one value has another value, and I see that much information about others are in store as QFT. Okay, maybe yes, and I'll use it, I suppose. And I see that there are some data that not have mutual information at all, and I suppose that I have to delete it, and I'll do. So another thing to find some new features is done by that plot, but there is no evident correlation to make new features. So new uh, features are made here by experiment, I suppose. Maybe I'm wrong, but for me it was a long experiment. Here it is. So I uh, made new features like this one. It had effects like this one. It had very small effects. And for new now I'm experimenting, but at first sight it made experiments worse. And in this contest I can only load five submissions at one day. It's the limitation. And here I make a new dataset for training where I add features, the new and old one, and I do not add some of them. How I decided not to add some of them? I decided it later, I'll tell you. So I have X, I have uh, XXX. They they differ. Some disappeared, some appeared, and I start XGBoost. And the result of XGBoost, I ask for feature importances. And at first time, they were all values, and the values with low importance I did not put in this list, in this dictionary list. Okay, and here I see that the new values are also have low importances and they make the result worse. Okay, as for the XGBoost, what parameters I used? I found them first by using grid search. It is commented because it's long time to for fulfilling this code, yes, and it gave me the result, this one, and I used it, but put here 200 and the same result I got. Uh, so I found this, then I experimented with L1 and L2, that's the regularization, and L1 had a positive effect and L2 uh, gave negative effect. So I use here squad error objective, and it's for a regression. Yes, the reg and RMSE evaluation metric. Okay, I experimented here with three methods: exact, hist, and yes, and that's all. I experimented here with GB3 and dot on that. The same results I got, but that is slower. But I'm using it. Okay, I made the interaction constraint experiment where I make dependencies in feature uh, communication in machine learning process, but it had no effect, but it was interesting. Okay, and what else? And I had this amount of experiments. um, it's a dark side of data analytics process, and here I got the score, but it differs uh, in the result of this one, of course, but nearly the same. So then I am I was loading I was working with my test dataset with the same steps, experimenting with normalization, made a plot, and same things as adding features and predicting, getting the prediction and put it in my file, and then loading it into Kaggle contest. So that's all. It is still going, and if something will change in positive direction, I'll put some comments in under this video. Okay, thank you very much for watching. Bye. Very interesting, Kaggle. You are the best.